This is Advanced Math 7.2 notes, and the title is Right Triangle Word Problems. Number 1, from a point 50 feet in front of a building, the angles of elevation to the base of a sign and the top of a sign are 45 degrees and 47.75 degrees. Period. Find the height of the sign. Now, some of the questions in the textbook will have pictures drawn for you, some will not. None of the word problems on the test will have pictures drawn for you. Okay, all of the problems on the test will be blank and have a blank space for you to draw your pictures in there on your own. Got it? Okay, so that is what we're going to do now. We are going to draw our picture. Okay, so we have our ground level. And we have our building. And we have our sign, our billboard. Advertising, whatever it is, advertising. Make sense? Okay. Now, from a point 50 feet in front of a building, the angle of elevation to the base of the sign and the top of the sign. Okay, so this is right there. So 50 feet from the base of the building. So here's the base, and you walk 50 feet away. So from here to here, you then look up. And angle of elevation is either from the horizontal line of sight or from the ground. In this case, it is from the ground. From the point 50 feet in front of a building, the angle of elevation to the base of a sign and the top of the sign, this is 45 degrees to the base of the sign, and then to the top of the sign is 47.75. So the 47.75 is not in that little piece right there. It's all of this together. Does that make sense? Which is why it's bigger than 45. So all of that together is the 47.75 degrees. Any questions? All right, find the height of the sign. So this right here is what we're looking for. It's the height of the sign. All right, so we're working with right triangles here still. In our second lesson for the day, 7.3, we will not be working with right triangles, but for this lesson we are. Now, it would be really nice to just work with this triangle there, that wonky non-right triangle, and find h. But it's not a right triangle, and because it's not a right triangle, we don't have the tools. We could do 47.75 minus 45, find that itty-bitty angle, but we don't have the tools to find that h. Do you see that? So we're not going to use that wonky triangle right there. What we're going to use is two right triangles. The two right triangles we're going to use is this big right triangle here and the small right triangle there. Do you guys see the two right triangles I'm going to use? The one here and the one big one here. All right, I'm going to draw them here. Now, they're both right triangles and they both have the same base. What's the base of both of them? What's the base of both right triangles? What is it? 50. Now the angles are not the same. The angle of the bigger triangle is the 47.75. And that makes sense because you're looking up to a higher height, so you're looking up higher, so it's larger. And the angle of the smaller one is 45 because you're not looking up as high. Make sense? Any questions so far? Okay, yes.
Wait, where is the smaller triangle coming from? The right triangle?
This one right here.
Oh, wait, no, I saw that one, but where's the other?
The larger one?
Mm-hmm.
This one right here. Including the sign.
Oh, okay.
Do you see them now?
Yeah.
Okay. So the smaller one is just to the building, and the larger one is to the sign, including the sign. Does everybody see that? I'm glad you asked. Okay. Pick up an assignment sheet over here, the yellow ones in the basket. And the assignments, the notes will be posted in Google Classroom. Okay. All right. Now I'm going to call this here X and this here Y. So this here is X, this here is Y. What I'm looking for is this height. Anybody tell me, once I find this X and this Y, X and Y, what would I do with those two values to find the height of the billboard sign? Yes? X minus Y. Does everybody see Y? Yes? Because, again, this is X, this is Y. If I do X minus the Y, will it give me the height of the sign? Make sense? Okay, so that's what we're going to do now. All right, so we're going to do height of the big triangle minus height of the small triangle. And that's going to give us the height of the sign. All right, so we're going to do what we did yesterday. I'm going to put my point here in reference to that 47.75. What is the x, opposite or adjacent? What is it? Opposite. And what is the 50? And what about for the 45? What is the y? And what is the 50? Okay, so which one is opposite over adjacent? Tangent of 47.75 equals x over 50. Tangent, and we're going to subtract tangent of 45 equals y over 50. Remember how to solve that? Here, you multiply both sides by 50. Plug that in your calculator. Multiply both sides by 50. Plug that in your calculator. Here you're plugging in 50 times tangent of 47.75. Here you're plugging in 50 times tangent of 45. 3 decimal places. All right, what'd you guys get for the first one? The second one is 50. And the first one is what? 55.046 feet and feet. And so when you subtract, you get what? So the height of the sign is 5.046 feet. You have one just like this on yours. That's actually the first one on your book assignment today. Any questions? Make sense? We're good? Okay, moving on. Next thing we're going to talk about is a bearing. What is a bearing? Where is it used? How is it used? Why is it used? Okay. A bearing is, or are, angles made with north and south lines. North and south lines. So you direct yourself north or south and then swing west or east. So I'm going to first draw this just to remind you. You never eat soggy waffles. Okay. Y'all remember that from elementary school? Okay. So, how do bearings work? You're going to have stuff like this. North, 30 degrees east. Your first part of your bearing is always going to be a north-south bearing. Your second one is always going to be east or west. Why? Because your first one is always a north-south line. So, your first line is always going to be a north or south line. Because this is north, your first line your first line's always going to point north or south. So first one's always pointing, in this case, north. And then you're going to swing yourself east. Which direction is east? To the right. So you swing yourself to the right, 30 degrees. Okay, an example of another one would be south, 47 degrees west. So this time you're going to draw what type of line first? A north line or a south line? And south goes which direction? Up or down? Down. So I'm going to draw my dot up here and draw a downward line. And then from this dot, which direction am I going to swing? If it's west, am I going to swing right or left? Left. So from here, from the scope, I'm going to go south, and then I'm going to swing 47 degrees west. I know directly that way is 90, halfway is 45, so a little bit more would be 47. So something like that. Make sense? Do you guys understand what a bearing is and how to draw it? Okay, try this next one on your own and then compare it, talk about it with your shoulder partner. North, again, first one's always north or south, 17 degrees west. Trinity and Pilar, I'm going to have the two of you move up one seat. All right, draw it, compare it with your shoulder partner. All right, so the first line is north. Will I be drawing my line up or down? Up, so I'm going to start from down here, go up, and then from down here, am I going to draw my next line from this dot to the right or to the left? To the left. 17 degrees is kind of small, so I'm going to have to make it a little bit bigger just so I can get a 17 in there. Okay, did it look, yours look something like that? Okay, any questions on what a bearing is and how to draw it? No? Okay, where are bearings used? Why do we have bearings? Like, we may not use them in our everyday lives, but who would use them and why? Anybody know? Like, why are bearings out there if we don't need them? Why do they exist?
For like architects maybe, so they know each and like which way to like, or like for word problems too.
Word
Like,
problems?
Which way to draw the triangle.
Okay.
A pilot to like find exact coordinates.
Pilots to find exact coordinates. What was that?
Miserable math students.
Miserable math students. Pilots, captains out at sea. A pilot, a person driving a boat, they don't have roads like we do in a car. They can't say, oh, go down Shaw, make a right on Blackstone, or go north on Bullard, and you know, they don't have those kind of roadways like we do in a car. Make sense? So they need bearings to get from point A to point B for directions. Make sense? To get from here to there, they need a bearing to say go north or degree east. Any of you guys see that Tom Hanks movie where he's on the ship and he gets attacked, and you know what movie I'm talking about? Which one is
Is
it?
it Wilson?
No, it's-
Not Castaway.
Captain Phillips.
Captain Phillips. In that movie, he talks about bearings, and he has his bearings on where he's going, and yada yada yada. But anyways, yes. So, and you can't mess around with that stuff and like, oh, around this and that. Like, you have to be exact, because if you are off a few degrees, what's going to happen? You're not going to, not necessarily die, but you're not going to end up where you're trying to get. You're going to end up being lost and, yes, possibly die. Okay, any questions? All right. Okay, we're going to move on to our road problems. Word problems, not road problems. Okay, number 2. Boat A. Can we see? Boat A leaves dock going north. Boat B leaves dock going north 37 degrees east. At 27 miles per hour. After 3 hours, boat A is exactly due west of boat B. How far apart are they? Okay. So boat A leaves dock going north. Boat B leaves dock going north 37 degrees east. Okay, so I'm going to make my dock here. They talk about docks or ports, their home base. I'm going to make it here since I'm going to be going north, and so I'm going to leave myself room to draw my picture. Okay, so this is, are they calling it dock? Yes, my docking station. And dock A goes straight north. Okay. And boat B leaves the dock, but he goes north 37 degrees east. So north 37 degrees east. Do you agree that would be this way here? Yes? And boat B travels 27 miles per hour. After 3 hours, boat A is exactly due west of boat B. So after so many hours, they are exactly like a right triangle. This is boat A, and this is boat B. And after 3 hours, boat A is exactly due west. So he's not at like an angle, he's exactly west of boat B. Do you understand why I drew the picture like this? Why he's at a exactly horizontal line like this? Yes? Okay. How far apart are they? So this is what we are looking for. We're looking for this distance here. Right now, all I know is that this angle here is 37 degrees. I'm looking for this x, so right now I do not have enough information. Would you agree? If all I know is that this angle is 37. So let's see what other information was given. Boat B is traveling 27 miles per hour. So boat B is traveling 27 miles per hour and is traveling for how long? 3 hours. What formula are we going to use here? It's a formula you learned back in maybe 6th, 7th grade.
What if we, yeah, so it's like, it's like 27 divided by 3 to get like how many miles.
Okay, so there's a formula we're going to use. What is it? Distance equals,
Wouldn't you just multiply 27 by 3?
Yeah, I was like, why are you?
distance equals rate times time.
I was going to say multiplication.
Multiplication is the formula. Distance equals rate times time. Yes? Dirt? Distance equals rate times time? You need an off-campus pass. Do you have your off-campus pass? And you're grabbing that, okay. Okay, distance equals rate times time. The multiplication formula, is that what you said?
Yes.
Distance equals rate, which is 27 times 3. And so go ahead and work that out. What does that come out to be? What is it?
81.
So distance equals 81. So the distance boat B has traveled is this distance right here, because that's boat B, right? Yes? So the distance boat B has traveled is 81 miles. Now do we have enough information to find x? Yes, because we have a right triangle. We can use SOHCAHTOA. I'm going to put my marker here. In reference to the 37 degrees, what is x? Opposite, adjacent, or hypotenuse? Opposite. What is 81? Opposite, adjacent, or hypotenuse? Which one deals with opposite over hypotenuse? Sine. So sine of 37 equals x over 81. Multiply both sides by what? 81. And now you're ready to plug it in your calculator, and you are done. Three decimal places. All right, what did you guys get? 48.747? Okay. So they're that many miles, 48.747 miles apart from each other. Yes? Questions? No questions? Okay.